Hello and welcome back. This is our second episode. My name is Christopher Gennady, Global Head of Research at Wisdom Tree, and this is the Next Big Thing podcast. Before we dive in, I do need to state the following. To clarify, the views and opinions expressed in this podcast are those of Wisdom Tree and the Consumer Technology Association and are subject to change. Anything we present in this podcast is not intended to be relied upon as a forecast, research, nor as investment or tax advice. The information and opinions expressed in this podcast are not a recommendation, offer, or solicitation to buy or sell any securities, and reliance upon them is at the sole discretion of the listener. Please remember, past performance is no indication of future results. All right. So I want to introduce the audience now to Rick Kowalski. We were so excited working with Brian Kaminsky in CTA that we are working again. We went back to CTA and we went back to the artificial intelligence topic. About a month ago, we spoke to Brian. And if anything, the topic is even bigger. The day we're recording this, Google, just to put it in context, Google has announced a whole variety of things that they are doing in the generative AI space to compete more head-to-head with Microsoft, maintain their leadership in certain areas like search. So the rivalry is heating up. But first and foremost, I wanted to give Rick an opportunity to share with us a bit about his background and a bit of about what he's doing over at CTA these days.
Yeah, thanks, Chris. Rick Kowalski. I'm Senior Director of Business Intelligence at the Consumer Technology Association. So we are the largest North American technology association, and our memberships span many different companies, large and small, anybody who's innovating and working in consumer tech. And so we see a large variety of applications, devices, services within our industry and our membership. And I work in the market research department here, so trying to pay attention to whatever's coming down the pike in the next 5, 10 years, and really trying to size up the market opportunity for our members and just for the U.S. market as a whole. And it's been a really interesting past, um, you know, day or two. I mean, it depends what time frame you look, but it just seems to be accelerating all the artificial intelligence that we're seeing in, among our members at CTA's big trade event, CES, of course, in January. Saw a lot of applications there. And just a little bit about where I come from. I've been working at CTA for 17 years now. I've been in the research department that whole time and just looking at emerging trends. But even before that, when I was in college, I was looking at one of my one of my majors was cognitive science, and some of that involved, looking at how the mind worked. But there were many my professors looking into natural language processing and trying to figure out how do we get computers to do what the human brain does. So even back then, and I'm dating myself a little bit, but 20 years ago, they were starting to talk about neural networks. And it was just a kind of a one little topic that I had heard about. That I was like, wow, they're really trying to, mimic what the brain does at the neuron level. And it's just amazing how far that's come. Perhaps I have some regrets about not pursuing a career in that. Uh, Natural language processing at that time was just starting to pick up, and it's just that has come so far. And you look at computer vision and all that. So yeah, it's been quite a journey, I think, for all of us, and really excited to see what's coming up.
No, and it's interesting that you mentioned sort of that connectivity between the computer, the human brain, the thinking about architecture, thinking about different means of getting what we call quote unquote thinking done within the various artificial neurons. It's been an active discussion, especially with Jeff Hinton in the last couple of weeks, essentially moving on from Google, talking about how he thinks about backpropagation with respect to neural networks and how that compares to what you're getting in terms of the output from the human brain, and wanting to understand more and more of what's happening with the human brain, and having maybe we'll get into some of the views that he seems to have about the comparison between backpropagation and the human mind and how that's all working. But so as not to leapfrog ahead too much here, Rick, I wanted to get your impression as somebody that's sort of been following the market and looking at topics like this, going all the way back to your university days, as you alluded to. When ChatGPT came out in, say, November, December of 2022, what hit your mind as somebody that, like you just said, natural language, you were there when you could barely get the machine to recognize what word you were saying, and now it's not perfect, but at the same time, you've got a system that can predict the next word in so many different scenarios and do it as accurately or even better than human beings. So I'd just be curious for you to take us through what you were initially thinking when you started seeing this.
Yeah, I think just the speed at which it has advanced. It was really kind of sudden, and I think it had to do with just it being released to the general public for the most part, and everybody starting to play around with it and start to realize, oh, wait a minute, this sounds and looks a lot like human language. This is very convincing, and it's spitting answers out to me that sound very natural. And just looking at that, how much that's leapfrogged, like you said, in the past 10 years, we've had digital assistants on our devices. But you look at how we've, come to use those for very simple tasks, telling your devices in your house to do this or that, or ask very simple questions. Now you're taking that to a conversational level. So I think that was the big advance for me, is just starting to see something where you could have a meaningful dialogue with it and have it follow the thread of a conversation. I think that consistency in a conversation is a pretty cool advance. Um, and yeah, and it's putting out very convincing, language. It appears very intelligent. I say appear too because I'm trying to keep in mind, all right, this is what the model's made to do. It's made to generate language and text that looks like human language. It's really good at doing that. But you have to remember, there may be some properties where it's starting to show intelligence in different ways. Maybe some very, low level reasoning, but at the end of the day, it's just a really well executed model based on statistics and a lot of parameters. So yeah, it was shocking. And then now, just in the past, 6 months or so, seeing what people are doing with it, and that's probably been the most important um, element here, is just seeing how people are using it. There's so many ways. People are trying to use it to help them with their jobs and write emails for them or get things done, learn, just figure out how to explain something to me in plain language at multiple different levels. So I think that has probably been the most shocking to me, is we're only at the beginning of this. It's when you really realize, okay, now we got something to work with here, and everybody can access it. Very
And Rick,
exciting.
I'm curious to know, again, as somebody with, say, much more context and sense of history within various developments of artificial intelligence than, say, the average person who might have only seen some of the biggest, broadest headlines, the things that everybody saw in, say, the New York Times or Wall Street Journal, Financial Times. Name your example. But you think back through the prior, say, 17 years, as you stated, your time at CTA, and you've had fits and starts of advancement where we were talking about advanced driver assistance systems and getting on the path to autonomous driving. And that's something that at various points it's kind of ebbed and flowed. Sometimes it's getting a lot of attention, it's perceived to be doing particularly well, and then other times, if you're to believe the prognostications, it may never happen in certain cities around the world. And similarly, computer vision. That was where Jeff Hinton and his original advance with his various students, some of which are now running research at various other firms such as Cohere or OpenAI. And you see the advance of using the GPU architecture in these models to increase the accuracy of computer vision. But you didn't necessarily, at least, and tell me if I'm wrong on this, you didn't necessarily see the same virality, the same uptake, the same capability of AI to now transcend the public consciousness on some of these other topics where a lot of work was done, and they certainly were exciting in their own right. But something about ChatGPT has captured the imagination in a way that these other things have not. And I'm just curious if you have any hypotheses as to why that might be.
I think with ChatGPT and these generative AIs, people were immediately able to see how it can affect them, and that it's become democratized now, so everyone has access to it. And this is what I look for in emerging technologies: is that moment when everybody can get a taste of it and everyone can get their hands on it. That just opens it up to so much more. There's experimentation, but also creativity and how you're going to use it. And begins to be its a foundation on which people can build. So you look for something like this where it has this, automatic all of a sudden network effect. Everyone's using it. You get competition that way. People are, trying to figure out the best way to use it. You get that element that helps accelerate innovation. Um, so I think that was it. Everyone could get their hands on it. And you look at something like self-driving vehicles, where that industry got very hyped very quickly. Everyone's like, oh, self-driving cars are coming in the next year or two. Everyone had this expectation that it was coming very soon before they really had a sense of, all right, what is the actual engineering problem here that we need to solve? And also, you're looking at something that deals with human safety, huge list of regulations, and there's a lot of context there where to get into this little in this discussion today is those risk factors that a lot of the government bodies who are starting to look at this are starting to take into consideration. So, ChatGPT, mostly low risk. You're dealing with text. You think about the impact it's going to have. Even if it spits out something that's not quite right, people have the understanding, or they're starting to learn. Okay, I can't believe everything that comes out of it, and that's part of the learning process right now. Uh, and what it's coming up with is based on human ideas that are out there in the public domain already. So, I think, with all of that said, I think it's just that democratization. Everyone's starting to be able to use it as a tool that you can use day in, day out.
And something that I definitely want to get into now is sort of thinking about some of these different use cases, because like you alluded to, and I guess one would hope that they cannot necessarily just see anything on the internet from just any old source and assume its veracity, assume its accuracy. Even before generative AI, maybe we could be kind to ourselves and say we had a few issues with that potential for misinformation. And we always have to maintain a certain level of vigilance on that front. But the interesting thing here is you're seeing some transcendence in the sense that it's not only that these models, these large language models, only go to text, predict the next word, and then go off in any old direction, in the sense that, and I know you and I have talked about this, but we'll kind of get into it here. Whether it's companies like Autodesk, Nvidia, and their Campus 360 platform, certain gaming applications, you're seeing the fact that you can take sort of the underlying principles and almost think of these different things almost like a language. And you see it as well in drug discovery, and the various rules about chemistry and proteins, and how all those things come together. But you almost think, okay, everything can be thought of as its own language, and these models can be trained on all these different languages. And then it may be the case that you can go from predicting the next word or series of words to predicting the composition of a new molecular compound or a new potential drug therapy, and then allowing for the human researchers to come in and to see, is this accurate? Is this something that is worth further pursuit? So I'd love for you, Rick, to talk a bit more about the transcendent properties that you're seeing in some of these models, where maybe it starts with text, but it doesn't necessarily end with text.
Yeah, you bring up a couple good concepts there. I think, I mean, a lot of the models that have been made up to now are looking more at other things other than text, imagery especially, or video. Um, and also some models are, and this is really the future, is getting multiple modes of input like text and image and sound all working together, coming into the model, and the model being able to process that in meaningful ways. But yeah, I think you're right. There's kind of two different types of models right now, and you look at ChatGPT, and it's kind of a generalist model. It's able to address a lot of different questions and answer different, go into different subjects, but maybe at a higher level. It's definitely, you're not going to go for an expert opinion from ChatGPT. But on the flip side, you have a lot of researchers who are applying AI, machine learning, to very specific problems that they're working on. And they may deal with different types of data that aren't text. Perhaps, think about a self-driving car. You have to deal with different types of visual information, perhaps even sound, and perhaps even the activity of the driver in the car. And you're trying to mesh all that and fuse that data together in a meaningful way that addresses very specific tasks and jobs that the AI has to do. So um, I think that's what you're going to see. You're going to see, most people have access to maybe these general models that they can use day to day that address a lot of different issues, a lot of different tasks at a high level, which will improve over time. But then you have very specific examples that continue to improve in these specific tasks that engineers are working on. Over time will just improve. Yeah, going to your other, and you mentioned a couple that I was thinking of. Like you look at Autodesk and NVIDIA Canvas, they have a more three-dimensional ways of looking at the world. How do you generate or design a new three-dimensional object? Whether it's a product or a piece of a car or a piece of factory equipment, or in the gaming space, how do you generate a potential map of the world you're working in that can automatically make you a 3D landscape or a variety of them for you to choose from in seconds or minutes, instead of having to go in there and build the whole thing from scratch. Now all of a sudden you're 30% of the way done, you're 50% of the way done just by using a model to do it. So that's going to be very transformative for some of these creative occupation, where they can really get some of that drafting done very quickly and then go in and tinker and fine tune as
I agree, and it's interesting. I went to the MTech Digital Conference last week, and Jeff Hinton was one of the speakers, and we were going into some different related areas, in the sense that a few presentations. So they basically outlined the problem. They said, if you think of developing a drug, And the end point that we all are very much aware of, and Rick, I know you're in the Washington, D.C. area, and this issue comes up all the time, is the fact that medicine costs so much money. And then you say, well, why does it cost so much money? Well, the rough statistics might imply that a company, be it Pfizer or AstraZeneca or Moderna, you name it, may have to commit $2 billion over a roughly 10-year period. And at various points along the way, there's a 96% chance that it's just not going to work out for whatever reason. You're thinking you're on a profitable path. It just doesn't go all the way through. We know it's absolutely the case. Not every clinical trial yields a fruitful result. And what it sounded like, and some of the firms that were presenting were like Scientia, and they were talking a bit about In Silico Bio, and it seemed as though, it didn't seem yet, and maybe we get to that point, it didn't seem that the idea was the AI and the generative model just creates the medication end to end, and you're just taking a new drug and it's done in a year. Like, it definitely did not seem that that's the case, but it seemed like more of what you're able to do is certain parts along the process, you step back and you're giving yourself more at bats, more shots on goal, to use a few different metaphors, and giving yourself the chance of finding that successful path a little bit sooner. And a little bit sooner can be hundreds of millions, if not billions of dollars, because successful drugs that are treating certain things for people around the world, what could be more valuable than extending the health span of a given individual? So I personally felt like the drug discovery angle, and I know we've talked about it before, Rick, the drug discovery angle is just such a powerful one, but it feels like NVIDIA is gearing up, certain other companies are gearing up to really think of that as one of the most important applications of AI over, say, the next 10 years. Would you agree with that based on what you're seeing at, say, CES or some of your other sources?
Yeah, absolutely. I think again, it AI just allows you to look at a lot of data all at once. And, in this case of drug discovery, and maybe, thinking back to the database of proteins that DeepMind made, looking at all of the, potential chemicals out there and being able to quickly identify, okay, now that we know, we have this database of different molecules, and we know what we know about, what we're trying to develop, we can automatically eliminate, X number of these examples as like just not feasible. Um, and that's something we couldn't do before. We were, researchers might have an inkling that this might work because, they might see some evidence of, some medicinal plant being used, and they have some hypotheses, but it's very trial and error, and that's the nature of research and development. Um, but now you have a lot of the legwork done for you. You can start to even look at some chemicals that you might not have even known existed, or to look at some approaches that you might not have thought of before. So yeah, researchers just have a lot more to work with, and a leg up if they have some of these tools that just help them get, like I said, gets you 30% of the way there, 50% of the way there, gets a lot of that early trial and error out of the way. That's amazing. It can really add to productivity for anybody.
It was fascinating to hear how it also means that you go about doing research in a different way. And we've seen a variety of examples of this. I always go back to the AlphaGo, AlphaZero sort of template, in the sense that initially, when you're thinking, I need to train this model, in this case with the rules of Go, I need it to look at let's say every game that was ever played. Let's let it process move by move every game that was ever played, and that's sort of one avenue that you could take. So one thing you could do in drug discovery is you could say, okay, I'm going to look at every paper that was ever written and every experiment, to the extent that they were captured in a way that can be digitized, every experiment that was ever done. And you say, okay, that's one avenue that can be taken, but you then say, what was it that we learned and that DeepMind learned? This is why DeepMind is such an amazing organization. They basically said, what if instead of looking at the past, we basically said, let's have the model play itself, simulate future games of Go. And can you get to the same place or possibly even better? And to make a long story short, they were able to make the artificial intelligence engine that powers the game of Go even better by simply having the system know the rules, understand, and play against itself. So you almost wonder for various, and you see it in autonomous driving. You see simulated systems being trained. It's not always the case that the 18-wheel semi-tractor trailer needs to be going up and down the road and up and down the road. You're simulating a lot of those miles. And that's potentially one way to get interesting results. Maybe in the drug discovery world, you're able to simulate, because the rules and laws of nature and chemistry are not, maybe we don't know all of them, but at the same time, we know a lot of them and can probably get useful information without even needing to do a lot of the physical experiments. So it almost changes the way in which you're approaching some of these discussions and some of these problems. I personally just find that fascinating.
Yeah, I like how you mentioned simulation and the adversarial adversarial networks that they use to train the models and test those odd situations, or kind of make the models more robust. And you mentioned simulation. That's a whole industry unto itself now, that there are companies that will make simulation environments for machine learning algorithms and artificial intelligence algorithms to test out their theories and to work through some of the basic scenarios that they need to work with, and to quickly spin up the model's capabilities with simulation first. Of course, needs to get that real-time testing as well eventually. But again, you see synthetic data sets being made to train models as well. So this is all, it's all. I think what's important to see here is there's a whole ecosystem now supporting machine learning, artificial intelligence, and I think and I went to a conference recently here with a lot of people in government and some of the applications in AI, talking about just the necessity. You're still going to need people in the loop who help train these models, to help fine tune them, to be there and make sure it's addressing the need, what you want in the end, to train it. So that's definitely quite a need for the human brain power still to work with these models, fine tune them, and to really make them uh, better and better over time.
And Rick, I noticed you said government there, and I know you're sort of in the thick of things in the DC area. That's where Consumer Technology Association's offices physically tend to be. And I am curious because it's almost like you always see on the side, whether it's Sam Altman and Sundar Pichai and others meeting with the Biden administration, Kamala Harris, whoever the specific person might be, and I think that might have even been happening last week. But it's absolutely the case that the government has a role to play. They also have a view that they try to get out there from time to time. But given that you're there and you're potentially even speaking to some of these folks, what are they? Because if you just see the headlines like me, you're sort of left thinking, okay, they really don't like Microsoft buying Activision. Like they just, whether you're in the UK or certain other places, they really seem to have an issue with big merger and acquisition activities. Okay, so you put that aside. And you get the impression they really don't like TikTok and the various things that TikTok is doing. So you say, okay, and you put that aside. But with all the noise on some of these other topics, and at the same time, they're dealing with the debt ceiling and they're dealing with other issues as well. You're sort of left thinking they clearly must have a view on large language models, generative AI, but it's not always easy to parse through all the nuances and think what is the reality of the government's view, because in a sense part of it is Pandora's box for this particular technology is now open, so putting it fully back inside the box is probably not an option. So it's going to come down to what are the best ways to use the tool in a manner that befits and helps ultimately society. So I'd love to hear, when you go to these conferences, like you just mentioned, what are the government insiders tending to say?
Yeah, there's a lot of elements and a lot of people thinking about it. I think ultimately the messages we're getting from the White House is, we need to create some kind of guardrails to, help steer how this is developed, but there's definitely an acknowledgement that this is powerful technology. It can help people in a lot of different ways. And we also need to make an environment that protects companies' abilities to innovate. And so I think that's really where the U.S. government is trying to figure out the right path forward right now. You see the National Institute for Standards and Technology came out with their um, risk management framework recently, and this tries to outline, okay, how do we, and this is really where I think we see other governments, EU is looking at risk levels. Like, how do you define certain levels of risk? What is acceptable? Ultimately, and this is what the NIST looks at, is what is the potential impact of these risks, and what's the probability? So, keeping that in mind and looking at the magnitude of what an impact could be, and is that very likely? So I think that's one element that people are trying to really figure out throughout the government. But again, like all the departments, all the various segments of federal government are also trying to figure out how do we use this to make us more efficient. You look at something like Department of Defense, obviously, other governments are trying to use this in ways in their defense industry and to try to figure out and try to keep up with one another. So there's that level of concern that there are going to be people who don't follow the rules. There are going to be scenarios where people and entities aren't using it according to these rules that people want to set. So you have to prepare for those scenarios, and that's another thing the government's trying to figure out. Stay ahead of it, be a leader in the world, guiding what's acceptable, and trying to come up with a more of a worldview and an agreed upon set of standards that we can use to guide the path forward. Because again, everyone realizes this is genie's out of the bottle, or it's out of Pandora's box. I've heard many toothpaste out of the tube,
Yep. Yep.
whatever analogy you want to make. It's definitely this train has left the station and the technology's there. It's a double-edged sword, and people are going to be experimenting, innovating, coming up with new ways to use it. And so, yeah, I think you see just a lot of the federal government trying to create some guidelines, some guardrails, so to speak, for U.S. innovation, at least here in the States, to try to figure out what we can do with this and not restrict it too much. Like you said, politics, of course, is gonna rear its ugly head from time to time, but again, you look at this and just all the possibilities have. Um, it could very well help governments become more efficient. So yeah, there's a a lot to be said, and I think a lot will be developing in the coming months and years because we're really at the onset of this, where awareness is really high within the government, and EU has already started to come up with its framework of how to deal with AI and risk levels, and the US is not too far behind, trying to do that for itself, uh, and just figure out the right path forward.
And I'm wondering because you step back and implicit to a lot of what we're talking about here is we've got the US and EU, and on many topics, the US and EU is at least tries to be an aligned entity with a set of common interests, a set of desires that lead the two regions to work together on certain topics. And you could say semiconductors and AI is seemingly one of those topics. And we're sort of reevaluating the supply chains across the world. And part of what comes up in discussion, of course, is you've got that island, Taiwan, 90 or so miles off the coast of China. You've got the various policies that have already been announced, where it's you're sort of hearing or trying to parse out what is happening on the more specific generative AI front, which is maybe a bit newer, but it's very clear what the government's view is on whether or not NVIDIA should be selling the A100 and H100 chips directly into China, and it's quite clear that the answer to that question is no. And then also exercising influence over ASML over in the Netherlands of selling certain equipment and manufacturing capacity type things into China, and the answer to that as well appears to be no. So I'm just wondering, as you look at it again, as somebody that's been following, because this isn't something that just suddenly 6 months ago we're suddenly in a rivalry with China. Maybe the news coverage makes it seem like that, but China has had the motivations that they've had for probably beyond even the 17 years that you've been at Consumer Technology Association. So do you sort of look at what's happening currently and think, it's actually going to be highly effective to restrict access to certain equipment, process technology, most advanced chips, and do you look at it and think, okay, China's going to have a very difficult time getting to the cutting edge, or do you take an opposite view and say, look, China's got a lot of research, they've got a lot of know-how, and they're going to be able to get to the goal no matter what we do. Maybe it takes a bit longer, but simply restricting the H100 or subsequent technologies, it's not going to do it, because I think this is one of the key discussions, sort of the U.S. versus China rivalry as it relates to AI and semiconductor technology.
Yeah, I think there's multiple factors going into that rivalry. And some of the original earlier restrictions put on China had to do with their surveillance of their own citizenry. So you look at that as one of those really hot topics and high risk, and what the EU might even call unacceptable risk of how you're using AI. But in the end, the U.S. is trying to use whatever leverage it can in its political tensions with China to gain an upper ground in the AI space. But this may lead to somewhat of different parallel paths to different AI models, or the same AI type capabilities over time. And of course, China hasn't stopped developing and innovating in the space as much as they can. So uh, yeah, does it put a little bit of a slowdown on their efforts? Probably. Um, but I think in time you can still build models. You may not be able to operate as quickly, without some of the newer technologies, but uh, they'll go ahead and try to build their own models and capabilities regardless. So yeah, I think in time, we'll see how that plays out. It's a little hard to tell right now, but definitely adds an interesting twist to just how this develops globally and and just the inability to separate these innovations, this new technology from culture, from politics, from these intergovernmental tensions. So, yeah, just an ongoing story.
And part of that story as well relates to some of the big names. I know we already mentioned Jeff Hinton. So he, in case anyone hasn't followed the story, he was a research fellow at Google for roughly a 10-year period after his firm was purchased by Google. So he was working with them on numerous different topics, and people should remember that in 2017, out of Google's research area came the paper which sort of outlined the transformer. And if you think of GPT, the T in GPT stands for transformer, and you're basically dealing with a specific way of setting up the architecture and running the system based on a lot of that original research. So we tend to think of OpenAI these days. We tend to think of Microsoft with its close relationship and investment in OpenAI, but do not think for a second that Google is taking any of that sitting down. They've got a huge amount of AI research and firepower, and it'll be interesting to see how they continue to bring it to bear. But you have these big names, and okay, so we've got Jeff Hinton being one, talking about some potential risks to the technology and needing to pay attention. He's got a very nuanced view, so just looking at the headlines may not uh, do him the appropriate level of justice. But then on the other end of the spectrum, you see, the moratorium for 6 month thing that came out, basically a month or so ago. And it's one of those interesting things where I'm not sure if anyone who signed it thought it was actually going to come to fruition, meaning everyone's going to stop doing research for 6 months. I don't think anyone actually had that view, but at the same time, the idea of guardrails, like you were saying, Rick, or the government needing to provide the appropriate guidance is important. And so some of these things may, be used as leverage to try to get to that point sooner. Maybe try to avoid what we seem to have in certain other markets where you're sort of waiting for the SEC to regulate certain things, and the market is, for lack of a better way to say it, sometimes a bit confused on those fronts. So, within the AI space, I'm just curious, how do you see the interplay between, say, the government, some of these big names, the companies? How does it all work out and come together? Because I think the consequence of it not coming together, you're in a dimension where a bunch of people are trying to make various types of progress, and it could increase the overall risk to the system. Maybe you have deep fakes, misinformation, various things like Jeff Hinton alludes to. These things don't have to be the consequence, but if we don't progress in a way that makes sense from the outset, that could be one of the paths that we ultimately wind up going down.
Yeah, I think it's what what's important is, and I'm happy to see, is that private industry is in conversations with the government, with talking to Congress people about and educating them. What is this technology? What are the capabilities? What's realistic? What are the risks? What are we doing to address those risks? Um, it's going to be essential that these groups and civil organizations, academia, are all talking to one another. And that's something that CTA is typically in the middle of those conversations as well. So trying to bring the right people into the room and understand each other and try to figure out, okay, what's the path forward? Okay, we need to protect privacy. We need to look at the possibility for misinformation, misrepresentation, and look at bias. How are we treating bias? But set up those figure out what the concerns are, set up those guardrails that everybody is in the clear. Okay, this is how we're going to move forward in with this understanding. What we don't like to see, especially in the states where you have 50 states who can all legislate on the same topic quite differently, and then you have companies are trying to figure out, all right, well, in California we need to do this, but in Colorado we have to operate completely differently. So it's good that we're looking at more federal solutions to these and starting to outline a path forward that everyone can agree on, or compromise to some extent and try to figure out, okay, we can do this and look at those situations where there's high risk and figure out how are we going to address that? How are we going to prepare for it? And you get everyone on the same page on that, and you're going to move forward a lot faster. So it's going to take time, of course, at the onset to start having those conversations. And I think right now what I'm seeing is education. It's educating our legislators, educating the public on what these models really are, what's really happening, and dispelling some of those sci-fi myths and some of those popular tropes that you see in sci-fi, and be really realistic about what's possible, what's happening now, what's likely to happen in the next several years. So again, I'm just happy people are talking about it. I'm happy people have it in their hands and are starting to understand it. That's key, definitely.
At the MTech Digital conference, the last presentation, I personally think it was one of the best presentations. So saving the best for last in a sense. It had to do with deep fake detection, and they were kind of going through ways in which there are systems out there that can consider. So one of the examples that stuck with me was there is a certain way in which when you're looking at a video and it's a regular person, the blood is obviously getting pumped through the heart, going up through the various arteries and coming back through the various veins. And you see in the skin. So if with an appropriate high resolution camera, your typical 4K cameras that are maybe out there today, you see the patterns in the pixels of the various shades of pink and red that have to do with, okay, the blood is moving through in a way in which that makes sense for a human being. And the reason that that's important is obviously if you're running a deep fake, I mean, obviously it's going to look like the person that it's intended to look like at first glance, because if it didn't, they wouldn't even put it out. But there are all these little things, these details that frequently are not done exactly the way in which they would be done if, in fact, the person was a real person and the image was being captured and it was, in fact, the real person. Now, the other side and sort of the other interesting thing is you have deep fakes, which, and I guess the term deep fake is the more pejorative term. So you sort of step back and you say, okay, if you're calling something a deep fake, it probably didn't have the permission of the user. It's probably being done to, spread misinformation or do something otherwise nefarious. But there is the expression digital twin, where there are, ways in which digital twins, which very well might have the permission of the user and might be getting used for a beneficial purpose, are out there. And these are also not the actual person, but they might be getting done in a manner in which has the actual person, maybe a politician's permission. You're in a world where now, at least in the virtual space, you might be able to be multiple different places at once and convey an important message that you would want to convey. And you sort of step back and you say, at least if you're not necessarily being misleading in any way. And I know in South Korea, sometimes politicians are actually even using this technology even today. But as long as people aren't being lied to, you sort of step back and say maybe there are use cases that make sense. So I think the way that whether it's digital twin, deepfake detection, there's an incredible array of kind of interesting things out there that are being brought to bear in today's world.
Yeah, you bring up so many different ideas there, but I think I like the notion that it's a cat and mouse game, right? And you're going to have something like a deep fake, but you're also going to have people and AI models that can detect them. So, it's going to kind of go back and forth, but I like this idea of, using this technology too as a way to create your own agents who can, do things for you, a personal digital assistant, perhaps that's, an avatar or replication of you that you give permission to make certain actions on your behalf. So it's like having little digital robots doing little jobs for you. So I mean, that's a really cool application that I think we'll see a little bit more of. But also, there's that idea of what's authentic. All right, how do I know this digital twin of Rick is, the true thing? So is there going to be some kind of system of authentication so we know who we're seeing, what we're seeing is the real deal or not? So we're going to have to navigate those waters. So so many things to consider.
Absolutely. And something, Rick, that I find interesting in this generative AI discussion, and I guess we'll see if it evolves in certain directions. But um, you feel like there is this overlap with the concept of automation, and certain investors out there, they kind of bring the two terms together: the idea of artificial intelligence, the idea of automation, sometimes even the idea of robotics, and everything gets mixed and mingled together. And depending on how these things are done, they could be quite different, or they could be parts of a multimodal model that you ultimately refer to. And you could envision a world in which robots are taking advantage of these models in different ways and interacting within their environment in ways that maybe weren't explicitly programmed. But then there's also a discipline that I know we've talked about before, robotic process automation, which at various points in time in 2018, it was probably one of the most exciting AI applications out there. I would say in 2023 so far, if I am not the one making the statement or I'm not talking to someone at CTA, it doesn't even come up at all. So it's completely fallen away. Doesn't mean that the companies aren't out there. Doesn't mean that it isn't an important service. Companies like UiPath, this is really what they're known for and what they're doing. But I'm just wondering, Rick, if you sort of see an environment where you look forward a few years, and part of what generative AI does is make certain tasks, certain jobs more efficient, easier, and what have you. And you're thinking of these robotic process automations. Are we going to get to a point where that rudimentary work that is very repetitive in nature, is that all being done by computers 5 years from now, and people are freed up to do more creative things? Do you think that's the direction we're heading?
Yeah, I think you'll see, anything that's a rote task, repetitive, or data entry, matching up data across perhaps different departments, things of that nature, or anything that's you know, frequently asked questions across staff members, you name it. A lot of these tasks will be automated. And I think, yeah, there's, a lot of these firms working in robotic process automation, and some of those tasks are, just identifying, common data structures across different platforms within an organization, or maybe process mining to understand where data tends to flow and if there's better ways to do that. So, using AI to identify places where you have potential for efficiencies, then setting up the processes, which are, maybe more of an automated task, wouldn't necessarily call it AI once it gets going, but the, the discovery beforehand and trying to figure out where those efficiencies are probably driven by AI. And then on the back end, or at the front end, where a employee is interfacing with these systems, you may see again some kind of AI layer like a chat GPT or some kind of large language model that helps people navigate these processes and helps them understand, all right, where did the data come from? Who's working on it? Who do I talk to? And so, I think you'll see a blend of, automation and AI, large language, all this process mining coming together. And ultimately, yeah, I think there are some tasks that people are going to be able to save time using AI in various ways in their day to day. And I think employees will start using this as a just a daily tool that just like we use computers today, it didn't replace my job, of course. It may have replaced some tasks and some jobs in the past, but now everyone who's employed or most everyone's interfacing with a computer at some point in their day to day. It's a tool that you use every day just to get things done and get things done smarter. And that's what I see, AI tools becoming. It's a tool. And like I said before, it's it's something that everyone's using. Some people will use it more effectively than others. So you'll see, run-of-the-mill uses, but you'll see shining examples of how this can be used and innovations that really take it to the next level. So I think that's where we're seeing some of the excitement in the next few years. It's just, look for those shining examples. You see the everyday applications of people posting, oh, ChatGPT told me this or that, and you might get a little chuckle out of it. But at the end of the day, there's people who are like, all right, let's take this to the next level. Let's tie in another model or, try to do some other more creative things. And you'll see, and again, this is why I like that it's democratized now. You'll see the cream of the crop. You'll see the things bubble up that you didn't think were possible. And that's the excitement of it being democratized.
And Rick, I think that's a great place to leave it today. I think it's been a great discussion. We've covered a lot of different topics, generative AI, plus a bit more, as well as a bit on the government side and the regulatory front. And it's going to be the only conclusion we can really make is it's going to be important to continue to just watch whether it's the rivalry between U.S. and China, the rivalry between Alphabet and Microsoft, the ways in which novel use cases that weren't necessarily thought of by even the creators of these systems are being brought to bear. All of these things are fascinating, and it's never a dull moment in artificial intelligence at this point in time. So, Rick Kowalski, thank you very much. It's been a pleasure, and thank you to all of our audience. Please come into the show, rate the show, and enjoy listening. You've been listening to The Next Big Thing. Take care.